Hello everyone, today I want to explain my homework 9.3. Today I will present my solution to the homework problem, which involved convert a given block diagram into a single flow graph. This presentation will work through the process step by step, explain the underlying concepts, and provide the final solution. The presentation is structured into 6 main parts. We will start with the problem statement, move on the fundamental of single flow graphs, discuss the conversation process, cover key concepts and methods, gain formula, apply all of this to solve the problem, and finally conclude with a summary. The task is straightforward. Convert this block diagram into a single flow graph. The goal is to transform the block and error representation into a node and bridge graph, which is often more effective for analyzing complex systems, especially when applying methods gain formula. A single flow graph, or SFG, is a powerful tool for representing layer systems. It uses nodes for singles and branch for transfer functions. Unlike block diagrams, which use summary, direction, and takeoff points, SFGs integrate these functions directly into the node and branch structure, making it a more streamlined representation for analysis. Converting a block diagram to an SFG involves 5 key steps. First, identify all singles. Second, create a node for each single. Third, replace each block with a bridge carrying its transfer function. Fourth, convert summary junction into node with multiply incoming bridge, remembering to include negative singles in the branch gains for subtractions. Finally, simplify the graph by removing redundant nodes if needed. To analyze SFG, we need to understand key concepts like forward paths, loops, and no-touching loops. These are essential for applying Moslow's gain formula, which allows us to directly compute the overall transfer function of the system without tedious graph reduction. The formula accounts for all forward passes and their interactions with the system's loops. Now let's apply the conversion steps to our problem. First, we identify all the key signals in the block diagram and assign each a node. These are access the input ES, the error single NS, the distribution, and YS, the output. Step 2 is draw the single floor graph. We connect the node based on the single floor in the block diagram. The forward path from XS to YS goes through G1S and G2S. The distributes NS adds directly to the single before G2S. The feedback loop from YS back to ES has a gain of HS, representing the negative feedback shown in the block diagram. This is our final SFT. As an optional step, we can apply measures gain formula to find the transfer functions. For YS by XS, there's one forward path with gain G1, G2, and one loop with gain G1, G2H. Applying the formula gives us the transfer function. Similarly, for YS by NS, the forward path gain is G2 with the same lap, leading to the second transfer function. This demonstrates the power of SFGS and the measures formula for quick analysis. In conclusion, we have successfully converted the block diagram into a single flow graph, which offers a more streamlined view of the system. This process highlights the utility of SFGS in control system analysis, especially when combined with measures gain formula for calculating transfer functions. This is all my homework 9.3. Thanks for your listening. See you.